Right now, somewhere in central China, a factory the size of San Francisco is building a brand new electric car every 30 seconds. You heard that right. In the time it just took me to say that sentence, another car rolled off the line. This is BYD's Megafactory, and what's happening inside it is something the auto industry has never seen before. We're talking thousands of robots, AI systems that can spot defects invisible to the human eye, and a level of vertical integration so extreme that BYD makes everything from its own chips to its own batteries to its own motors, leaving almost nothing to the outside world. And to understand how they pulled this off, you have to go back to where it all started, not with cars, but with something you'd never expect. From batteries to billions. In 1995, a 30-year-old chemist named Wang Chuanfu scraped together about $300,000 and started a company in Shenzhen, China. He wasn't building cars. He wasn't even thinking about cars. He was making rechargeable batteries, the kind that powered your old Nokia phone. And here's the thing most people don't realize. Wang didn't have access to the expensive automated equipment that Japanese battery giants like Sanyo and Panasonic were using. So he reverse-engineered their manufacturing processes and replaced the machines with something China had plenty of people, hundreds of workers, doing by hand what robots did in Tokyo and Osaka. It was scrappy. It was unglamorous, but it worked. His production costs came in 5 to 6 times lower than his Japanese competitors, 5 to 6 times. And the quality was close enough that by 1997, in the middle of the Asian financial crisis, while other companies were collapsing, BYD was signing contracts with Philips, Panasonic, and Motorola. But Wang wasn't satisfied just making batteries for other people's products. He wanted to build something bigger. So in 2003, he did something that confused almost everyone in the industry. He bought a failing state-owned car company called Xi'an Qinchuan Automobile. Analysts laughed. A battery guy making cars? It made no sense. But Wang understood something they didn't. He knew that the future of the car wasn't the engine, it was the battery. And he already owned that technology. The first few years were rough. BYD's early cars were forgettable. Sales flatlined for over a decade, hovering around 400 to 500,000 vehicles a year while competitors surged ahead. It looked like the doubters might have been right. But then, in 2022, Wang made the most aggressive bet of his career. He killed every single combustion engine vehicle in BYD's lineup. No hybrids as a safety net, no gradual transition, just a clean break, pure electric, and plug-in hybrid. Nothing else. The industry thought it was reckless. 2 years later, BYD posted $107 billion in revenue, surpassing Tesla for the first time, and sold over 4 million new energy vehicles in a single year. The battery guy had become the biggest electric car maker on the planet, but that was just the beginning, because what BYD was building behind the scenes would make that sales number look like a warm-up, the cathedral of automation. To understand what BYD has really built, you need to step inside one of its factories. And not just any factory, the one in Xi'an, in central China. This is BYD's oldest and most prolific production facility. It's been running for over 20 years. And in late 2024, it crossed a milestone that almost no single automotive plant in history has ever hit 1 million electric vehicles produced from a single site. Let that land for a second. One factory, 1 million EVs. 4 separate assembly lines run simultaneously inside this complex, and together they push out between 4,000 and 4,400 finished cars every single day. That's roughly 3 cars per minute. Not 3 cars started, 3 cars completed, inspected, and rolling off the line ready for delivery. And here's what makes it even more staggering. 97% of the work happening inside this building is done without human hands. The welding shop alone has over 300 robots. The painting line is 100% automated. Not a single human painter touches a vehicle. 131 welding robots operate on the welding line with over 90% automation. Automated guided vehicles, AGVs, silently ferry parts across the factory floor, navigating themselves using industrial 5G connectivity that covers the entire complex. Intelligent warehousing systems pull and deliver components exactly when and where they're needed, down to the second. But Xi'an isn't even BYD's most advanced plant anymore. That title belongs to a newer facility in a place most people have never heard of, Xiaomou, in the Shenzhen Shanwei Cooperation Zone. This factory only started operations in September of 2023, and it's already producing one finished car every 60 seconds. Every 60 seconds. That works out to about 1,280 vehicles a day, or over 400,000 cars a year from a plant that didn't exist 3 years ago. And it's not just fast, it's strategically located in the heart of China's EV supply chain corridor, surrounded by manufacturers of brake systems, suspension components, and seats, all within delivery distance. Now here's what separates BYD from almost every other automaker on Earth. They don't just buy their robots and plug them in. BYD designs and builds its own automation tools, its own assembly line equipment, its own production systems. They've partnered with companies like Guangzhou Risong, JEE Tech, and Dalian Hausen to continuously push the boundaries of what their lines can do. They've signed contracts for over 10,000 new robots to further automate both their vehicle and battery factories. And they've even started deploying humanoid robots, actual walking, carrying, inspecting humanoid machines built by a company called UB Tech on the factory floor. These robots conduct visual quality inspections, carry parts of different sizes, tighten screws, and sort components. The goal isn't just automation, it's full autonomy. Factories that can run in the dark, 24 hours a day, 7 days a week, without a single person on the floor. But the robots and the speed are only half the story. Because what's really running these factories isn't something you can see, and almost nobody outside the manufacturing world knows it exists. The AI brain behind the line. If the robots are the muscles of BYD's megafactories, then artificial intelligence is the nervous system. And what BYD has done with AI inside its production facilities is something most people have absolutely no idea about. Picture this. On every single assembly line, at every single station, sensors are feeding data constantly. Temperature, pressure, alignment, material composition, electrode positioning, all of it streaming in real time to a network of neural networks that never sleep, never blink, and never get tired. These AI systems are analyzing information at a speed and resolution that no team of human inspectors could ever match. They're catching microscopic deviations in how a battery electrode is aligned, deviations so small that the human eye wouldn't detect them even under magnification. They're monitoring the exact chemical composition of materials flowing into each cell and flagging the slightest irregularity before it becomes a defect. And the results speak for themselves. BYD has reported a 40% reduction in battery defects since deploying these systems. A 40% drop. On top of that, average battery lifespan has improved by 20%, not because of a change in chemistry, but because the manufacturing process itself has become that much more precise. Every weld, every seal, every connection is now optimized by machine learning algorithms that get smarter with every single unit produced. They learn from past defects. They adjust parameters in real time. They predict failures before they happen. This isn't quality control, it's quality prediction. But BYD didn't stop there. They built what engineers call digital twins, complete virtual replicas of their battery manufacturing environments. These aren't simple 3D models. These are living simulations where engineers can change a variable, say, the temperature in a curing chamber, or the speed of an electrode coating line, and watch exactly how it ripples through the entire production process. They can test 100 different configurations in a single afternoon without touching a single physical machine, without wasting a single cell, without stopping production for even 1 second. That's the kind of advantage that compounds over time. Every optimization feeds into the next one. Every improvement becomes the new baseline. And then there's what's happening on the final assembly lines in Zhengzhou. 16 fully automated production lines run around the clock. AI software orchestrates every task, from chassis welding to battery installation to final inspection. Machine vision systems verify every torque setting, every paint finish, every panel gap. The result is a 30% improvement in overall production efficiency. That means BYD isn't just building more cars, it's building better cars, faster, with fewer errors, at lower cost. Most automakers talk about smart factories as something they're planning for the future. BYD is already living in that future. And the AI is only one layer of the advantage because underneath all of it sits a manufacturing philosophy so aggressive that it would make Henry Ford himself nervous. Vertical integration, the ultimate weapon. Here's something that might surprise you. When most car companies build an electric vehicle, they buy the battery from one supplier, the motor from another, the chips from a third, the software from a fourth, and then bolt it all together in their own factory. That's how the auto industry has worked for decades. Layers upon layers of suppliers, sub-suppliers, contracts, logistics chains, and middlemen, all stitched together across dozens of countries. It's complex, it's fragile, and when something breaks like it did during the pandemic, the whole thing falls apart. BYD looked at that model and said no. When investment bank UBS tore down a BYD seal to analyze how it was built, what they found stunned the industry. 75% of the components inside that car were made by BYD. 75%. For comparison, a Volkswagen electric car of similar size and class produces roughly 1/3 of its components in-house. That gap isn't small, it's a chasm. And it explains almost everything about how BYD builds cars cheaper, faster, and more reliably than nearly anyone else on the planet. So what exactly does BYD make in-house? The answer is almost everything. Through its subsidiary FinDreams Battery, BYD manufactures its own battery cells and packs, including the now famous Blade battery. Through FinDreams Powertrain, it builds high-efficiency permanent magnet motors and complete electric drive systems, including an 8-in-1 powertrain unit that integrates the vehicle control unit, battery management system, motor controller, power distribution module, drive motor, transmission, DC converter, and onboard charger, all in a single compact package. Most automakers need 8 separate suppliers for those 8 systems. BYD needs 0. Then there's BYD Semiconductor. This division produces the company's own IGBT chips, insulated gate bipolar transistors, which are the critical high-power switches that control electricity flow from battery to motor. These chips are the heartbeat of any electric powertrain, and BYD is one of the only car companies on Earth that makes its own. When the global chip shortage hit in 2021 and 2022, Ford and General Motors were forced to shut down entire production lines. Factories went dark. Dealers ran out of inventory. But BYD? BYD kept building. In fact, they increased production while their competitors were paralyzed. That single advantage, the ability to keep producing when everyone else couldn't, helped BYD capture market share that it has never given back. And they're not stopping at IGBTs. BYD Semiconductor is now developing its own AI chips capable of 80 trillion operations per second, designed to compete with offerings from NVIDIA. They've also partnered with TSMC and MediaTek to develop a 4-nanometer smart cockpit chip. The goal is clear total technological self-sufficiency. But vertical integration doesn't start at the factory. It starts in the ground. BYD has secured lithium mining rights in Chile through a partnership with SQM, one of the world's largest lithium producers. It holds mining interests in Zimbabwe, and it recently acquired mineral rights in Brazil's Jequitinhonha Valley, a region known as Lithium Valley, spanning over 850 hectares. From the raw ore in the earth to the finished car on the lot, the value chain stays almost entirely within BYD's walls. The financial impact is brutal for the competition. Internal analysis shows that a BYD vehicle comparable to a Tesla Model 3 costs roughly 15% less to manufacture than the same car built at Tesla's Shanghai Gigafactory. Battery packs produced in-house cost 20 to 25% less than those purchased from external suppliers. Those savings go straight to the consumer in the form of lower prices, or straight to BYD in the form of reinvestment. Either way, the competition loses. And the most powerful product of that vertical integration, the one that changed the entire battery industry, was something BYD had been quietly engineering for years. The Blade battery engineering, a revolution. For years, the biggest fear holding people back from buying electric vehicles wasn't range, it wasn't price, it was fire. Lithium-ion batteries, the kind that power almost every EV on the road, have a well-documented tendency to enter something called thermal runaway. That's when a damaged or defective cell overheats, ignites, and sets off a chain reaction that can engulf an entire battery pack in seconds. It's violent, it's terrifying. And for a long time, it was the elephant in the room that no automaker wanted to talk about. BYD didn't just talk about it, they solved it. In 2020, BYD unveiled the Blade battery, and it changed everything. The Blade battery uses lithium iron phosphate chemistry, known as LFP, no nickel, no cobalt. Those two materials are not only expensive and difficult to source, they're also the primary reason conventional lithium-ion batteries are so prone to thermal runaway. LFP is inherently more thermally stable. It doesn't release oxygen when it breaks down, and it produces far less heat under stress. But chemistry alone isn't what makes the Blade battery special. The real breakthrough is in the design. Each cell is shaped like a long, flat blade about 38 inches long and 3.5 inches wide. These blade-shaped cells are stacked side by side in a honeycomb array and inserted directly into the battery pack with no intermediate modules. This is called cell-to-pack technology, and it eliminates an entire layer of structural packaging that conventional batteries require. The result is a 50% improvement in space utilization compared to traditional LFP battery blocks. More cells in the same footprint, more energy in the same space. And in BYD's most advanced configuration cell-to-body, the battery pack actually becomes a structural part of the vehicle's frame. It's no longer just a component sitting under the floor. It is the floor. That lowers the center of gravity, improves handling stability, and frees up interior cabin space. But here's where the Blade battery truly earned its reputation. BYD subjected it to the nail penetration test, considered the Mount Everest of battery safety testing. In this test, a steel nail is driven straight through the center of a fully charged cell, forcing a catastrophic internal short circuit. With a conventional ternary lithium battery, the result is immediate flames, smoke, and temperatures that can exceed 1,000 degrees Fahrenheit in seconds. When BYD drove the nail through a Blade battery cell, there was no smoke, no fire. The surface temperature reached only 86 to 140 degrees Fahrenheit. They then crushed it, bent it, heated it in a furnace to 572 degrees Fahrenheit, overcharged it by 260% every single time. No fire, no explosion, nothing. And BYD didn't stop there. In March of 2026, they introduced the second-generation Blade 2.0. This version uses an advanced LMFP composition that delivers a 40% jump in energy density, pushing range up to nearly 430 miles on a single charge. It supports over 3,000 charge cycles and is projected to cost 15% less than the original. The Blade battery has become so respected that other manufacturers are now lining up to use it. Toyota has adopted it for the BZ3 sedan. And in a twist that few saw coming, BYD's battery subsidiary FinDreams now supplies cells to Tesla's own Shanghai Megafactory for its Megapack energy storage products. The company that was once dismissed as a scrappy battery startup is now supplying batteries to its biggest rival. But even the Blade battery is just one piece of a much larger machine, because to truly grasp the scale of BYD's dominance, you need to zoom out and see what they've built across the map. The Megafactory network production at continental scale. Most people hear the word Megafactory, and they picture one building, maybe two, a single massive complex with a famous name attached to it. But BYD isn't operating one Megafactory. It's operating an entire network of them spread across China and now reaching across the globe, and the combined output is unlike anything the automotive world has ever produced. Inside China alone, BYD runs 9 major vehicle production bases: Xi'an, Shenzhen, Changsha, Zhengzhou, and more. Together, these facilities give BYD an annual production capacity of 5.82 million vehicles. To put that in perspective, that's more than the entire annual output of BMW, Mercedes, and Audi combined. You heard that right, one company. More capacity than 3 of Germany's most iconic automakers put together. Each factory in this network serves a specific role. Xi'an is the workhorse, the veteran plant that proved BYD could manufacture at massive scale, pushing out over 1 million EVs and still accelerating. Xiaomo is the speed factory, the one that rolls a finished vehicle off the line every 60 seconds, located right in the middle of China's densest EV supply chain corridor. And then there's Zhengzhou, the crown jewel. 5 of its 8 planned phases are already operational. 16 fully automated lines run 24 hours a day, 7 days a week. When all 8 phases are complete, this single complex will produce over 1 million vehicles per year from a footprint larger than Manhattan. It's not just a factory, it's a city. Worker housing, soccer fields, recreation centers, an on-site battery production facility, even a racetrack for vehicle testing and development. Nearly 60,000 employees live and work on the grounds, and that number is expected to grow dramatically in the coming years. But BYD wasn't just scaling inside China, it was replicating the model worldwide. In Camaçari, Brazil, on the site of a former Ford factory, BYD invested nearly $1 billion to build its largest production facility outside of China. It's already producing 150,000 vehicles a year, with plans to scale to 600,000 at full capacity. In Szeged, Hungary, a $1.3 billion plant is under construction, aimed squarely at the European market and expected to open by 2026. In Thailand, another facility is already operational, with a capacity of 150,000 vehicles per year, and new plants are being built or planned in Indonesia, Turkey, and Cambodia. This isn't random expansion, it's calculated. Every new factory is positioned to reduce tariff exposure, shorten delivery times to regional customers, and insulate BYD from the kind of geopolitical disruption that could cripple a company dependent on a single country for production. And here's the part that most people miss entirely. BYD isn't just building cars in these factories for its own brand. It's becoming a supplier. Other automakers are now purchasing BYD batteries and powertrains to put inside their own vehicles. That means even when you're buying a car from a competing brand, there's a growing chance that the technology inside it was made by BYD. And there's one more layer that rarely gets talked about. These megafactories aren't just productive, they're sustainable. Over 1 million square feet of rooftop solar panels feed power directly into the Zhengzhou complex. A closed-loop water recycling system handles all wastewater on site. Rainwater is collected, filtered, and channeled into the cooling systems, cutting overall water consumption by nearly 40%. BYD isn't just building at scale, it's building with a footprint that shrinks as its output grows. So when you step back and look at the full picture, the 9 Chinese megafactories, the global expansion into 4 continents, the vertical integration from lithium mines to finished vehicles, the AI systems running the lines, the blade battery rewriting safety standards, and a production capacity that dwarfs some of the most storied names in automotive history, one thing becomes very clear: the factory that builds the future. This is no longer a competition between car companies. This is a competition between manufacturing philosophies. And right now, BYD's philosophy is winning. In the first quarter of 2025, BYD overtook Tesla to become the world's largest electric vehicle maker by sales. By the end of the year, BYD had sold over 2.25 million pure electric vehicles, compared to Tesla's 1.64 million. Its revenue had already surpassed Tesla's the year before. Behind those numbers sits 120,000 engineers, a culture of daily patent submissions, and a manufacturing infrastructure so vast and so integrated that no other company on earth can replicate it, at least not anytime soon. And that's the real story of BYD's Megafactory. It's not just a place where cars are built. It's a machine that builds competitive advantage, layer by layer, robot by robot, battery cell by battery cell. From a $300,000 startup making phone batteries in Shenzhen to a $107 billion empire producing a new electric vehicle every 30 seconds, BYD hasn't just entered the auto industry. It has rebuilt it from the ground up. And every 30 seconds, the gap between BYD and everyone else gets a little bit wider.